This cradle really works great for moving the Bridgeport. Slider underneath. Yeah. I'll lower it down on there, and then I'll put a skate in the front. Got the Bridgeport moved, wasn't bad at all. And I've been doing a lot of cleaning. And if you ever wanted to know what was behind my sticker boards, there you go. It's a furnace and a water heater. Comes out over on this side. So that pipe back there, this one here is the one I got to replace. Goes underneath everything, way down the bottom there, and then it goes outside. So getting everything moved out of the way, I think, was the hardest part of the whole job. So tomorrow we'll start replacing the piping. While I was replacing this drain piping, I took the opportunity to finally put in a new return pump for the domestic hot water. My original pump failed over 20 years ago and 3 water heaters ago. So there's been nothing here for a long time. So I got a new pump and I put all this new piping in. It came out really nice. I made these mounting brackets. Everything's working good, no leaks, but over here on this shutoff valve, this valve is from almost 40 years ago, and right here on the bottom, this solder joint has a pinhole leak. And one thing about solder joints on anything old like this, there's no way you're going to be able to resolder it. It has to be disassembled, completely cleaned, and then resoldered. So I've got to address this. I've just drained all the water out, and I'm going to take out this section of piping. I'm hoping I can disassemble this valve. It's much easier to do the soldering and to clean this up if I can get it apart. So that's our plan. Otherwise, I'm going to replace this valve, which is not going to be any fun because trying to get water out of an existing system, I just blew air through it, so I think I got most of it out, but I would rather not replace this valve if I can get it apart. So that's the plan. I had to get the big wrenches out. These things are extremely tight, but I got it to break loose, and I got just enough room to unscrew that. So with a little bit of luck, by the way, I'm going to put the cover back on that electrical outlet. I did some painting, so I took it off. Okay, so there we go. How's it look up underneath there? All right, I'm going to give this a quick inspection to make sure it's worth reusing this valve. Okay. All right, so I inspected the valve and our fitting piece here, and it looks fine, so we're going to reuse it. I am going to replace this section of piping to get rid of this coupling. So this solder joint is just a poor solder joint. It was probably never good to start with, and it just degraded over time, and now it's leaking. So I'm not going to try to build this whole thing on the bench, but I will solder this in. We'll make this one our final joint once we assemble everything, because the odds of getting this lined up exactly so that our 90-degree offset is the same, pretty slim. And in case this doesn't work, I do have a contingency plan to just replace the entire valve. But There's almost no solder penetration in there at all. No wonder it was leaking. That's terrible. All right, let me clean this up. Okay, just a quick discussion and then we'll get on with the repair. So when I did the original plumbing on the house, it was right when they banned leaded solder. So we had to use lead-free solder. And there was quite a learning curve with the manufacturers of what they could provide that was cost effective and would work without lead in it. And some of the earlier ones were not so good. Okay, one of the problems was it required a higher temperature, and the fluxes that were available then didn't work too good at higher temperatures. They tended to burn out. You had to be real careful not to overheat your fittings. So over time, they've learned that the only thing that really works is you got to have silver in the solder. So this one works pretty good. This one, Silver Bright 100, it has a 0.5% of silver in the formula and a little bit of copper also. This one has been around for a long time, but it's expensive. Stay Bright, I think this one is about maybe 2% silver. I'm just guessing, but it's definitely more than this. This works really good. It's it does require, you know, a little higher temperature as well. And then of course this was the old standby 50-50 tin and lead, which worked fantastic. Okay. So one of the things they've reformulated the paste flux, so now it will work at a higher temperature. If you got an old can of this stuff, just throw it away. Get a new one with the new formula. You'll be better off. If you've got a really difficult, dirty fitting, you want to go with one of these liquid fluxes. This is a very aggressive one. It's actually designed for stainless steel. Soft soldering stainless steel is very difficult. You need a very powerful flux to eat through and break through that oxide layer. So I might use this to do this, at least just this one. And I'm trying to decide, do I want to use the Stay Bright or do I want to cheat and go back to 50-50? I think I'm going to try the Stay Bright. So anyways, let's go for it. Okay, I cleaned this really good. But there's still a little discolorations in there, so there may be, down in the pores of the metal, there may be some corrosion still down in there. So we're going to use the liquid flux. I think the primary ingredient is hydrochloric acid on that stuff, so I got to be careful with it. Okay, let's see if we can get this soldered. And we are going to use the Stay Bright.
Anyway, keep that handy.
I'm doing this horizontal. I don't want to take the chance of any solder running out the bottom and interfering with our valve. I'm going to put a cap on it just to be on the safe side. Good enough. Alright, it's a little disgraceful on how overboard I went with the solder, but I do not want this to leak. I could tell by the way it was flowing, we got good penetration. In fact, you probably can't see it on camera, but I can see inside that the solder made it all the way through. Yeah, this is what we call chroming. And, you know, if this is on a commercial job, I'd have to redo it. That's not acceptable. But in this case, we're looking for no leaks versus appearance. Okay, let's put it back together. All right, we got our valve back together, and it appears to still work. It's a little tighter than it was. I think I tightened this a little more than it originally was, because there is a seal in there that pushes against the ball. Okay, I do have the water shut off. You do not want to take one of these apart. You have to have no pressure on either side, because there's nothing that will hold that ball in there once you take this end cap off. So, a little safety warning. It's going to be too hard to film the soldering, but here's the setup. So I got a little piece of baling wire here to hold this up. As soon as you heat up that elbow, it's going to want to drop off. And we have a slight misalignment because this is dropped down a little bit without the support. So anyways, that's the setup. Let me solder this and we'll see how it works. Looking good, guys. It's been running a couple hours now. No leaks. I wanted to make sure this pump runs good. I've got a little timer, a remote control timer that I'm going to plug in for the pump here. And I'm going to put some insulation on the piping, and we're going to call this one done. This pump is super quiet. Can't even tell that it's on. The only way you can tell it's working is that the pipes stay hot. So I like that part of it. I jockeyed around the location of the Bridgeport, and this is something I've been thinking about for quite a while, just to try to gain, you know, a fraction more space. So if you look up top here, you can see the electrical outlet on the ceiling that used to line up with the mill. So we gained about 4 inches. We're a little tighter to our cabinets over here, but I think we can live with that. The whole goal here is to get a little more space over here because we have our little horizontal mill that we want to put in over here. I'm slowly getting everything put back in place, and it really helped to move this Bridgeport over about 4 inches. It made more room for this little mill, which is still a project that we need to get to. I've got to modify the base for it. The base is kind of tall. It would actually be, the table height would be taller than the Bridgeport, and I'm going to modify that base so they're about the same height. And then kicking the south bend over a few inches, bringing it out and that way. That helped as well. I got a little more room to maneuver here, and I can still get to the toolbox, no problem. Plenty of room for the drawers to open. So yeah, I think that's a big improvement. So got a little bonus outcome after doing all these plumbing repairs.